So now we're at question 6 of the multiple choice. So the question is, acid catalyzed hydration of 4-phenyl-1-butene would yield which of the following as the major product? So here we're just looking for the major product. There are other possibilities, but we're just considering the major. So first thing that needs to be done is to draw out the structure that's given. So you're given 4-phenyl-1-butene. So I drew that out here in the abbreviated form that Dr. J shows below for the answer choices. But sometimes I like to, since this is a common question, usually it's testing to see if you're alert for at spotting shifts, methyl or hydride shifts. So it's good to draw out the benzene just to see if there's a possibility to shift to the benzoic position. But here later, as we'll see, there isn't. So as these mechanisms go, we're given acid catalyzed conditions. So the double bond grabs an H from the H2SO4, and you're left with a carbocation. And the carbocation always is going to want to be placed on the more highly substituted position, or the most stable position. Here we had a choice between primary and secondary. You could very well get a product, a minor product with a carbocation on the primary, but here we're just looking for the major product. So here we put it on the more stable position, which is the secondary, and then we look, okay, can we shift anywhere to get better? So we look directly next door, and we don't want to shift to a less stable position, so we can't shift that way. And then we look on the other side, excuse me, and we see if we can shift that way. Well, here you'd be going to a secondary, which isn't any better. You only want to shift if you can get to a better position. So you can't do any shifting right here since you're not directly next to the benzene. This would not be the benzoic position. And if you can't shift to this secondary position and then shift to the benzoic position, it doesn't work like that. You can't shift to the same type of position. So this is where the carbocation is kind of stuck. So then water can come in and add to the carbocation. Remember, this is a non-stereoselective carbocation mechanism, so it can add either from the top or the bottom. I'm just going to show it as lines because that's how it is in the answer choice. I just drew them in the plane of the paper. So here we have our water added to it, and just to finish off the mechanism, I showed water coming in and deprotonating and reforming the acid catalyst. And this is the product that's formed, which is shown like this on your answer sheet, or on the answer choices. And this was answer choice C. Just, I think, flip upside down a little bit. So, answer choice C.